So the topic of the webinar is reference architecture for cross-border and cross-sector energy data exchange. And our webinar, most of the presentations are based on the recent Bridge report. The report itself is not yet publicly available, but we hope it will be soon. Anyhow, we are here to present the results. In fact, we're talking two reports, but the main one, the focus on which we have today is about the reference architecture for data exchange. And then there's another report for which we have one presentation relates to the flexibility assets interoperability. I'm representing Elering, which is the Estonian transmission system operator for electricity and gas. But even more, I'm here to because I'm part of two major Horizon 2020 projects. One of them being EU SysFlex, which is approaching its end very soon. And the other is OneNet, which has quite recently started. And the focus of the both projects is on the flexibility market. So we are facing the situation where the share of renewables in the electricity system is increasing sharply, and the assets in the grid are more distributed, variable. We can speak about electrification, etc., etc. So to address all those challenges, we need some more flexibility in the system. But that's not the full story. For the flexibility to work, we need proper tools and methods, and one of them is the ICT. So in fact, here we are talking today the information and communication technologies enabling these flexibility markets to work. Let me now briefly introduce what is a bridge, because this event we're having now, it is organized by the Bridge. Bridge, in fact, is a cooperation platform for the Horizon 2020 projects. Here it is. So, and it's mainly in the four areas. It's the smart grids, energy storage, islands, and digitalization. And the Horizon projects, which have been financed through these respective calls, they are cooperating in this bridge platform. And it has started already in 2014. So by the time when the Horizon 2020 program started, so the Horizon 2020 is the research and innovation program financed by the European Commission. And many projects, I believe in total, something around 100 projects have been incorporated under the bridge during these past years. Couple of slides to highlight what is the nature of those projects participating in the bridge. So here it's the distribution by the technologies, or let's say so-called technologies, because you can also see the market here, which is quite important. But obviously also some specific technologies like grid or generation. And you don't see here specifically the ICT, information and communication technologies, but that's because it is spread all across those different domains shown on this screen. And the other figure here, it's more maybe clear in that perspective. You see that it's the share of different types of participants in those projects. You see that the ICT providers have taken quite a relevant share here, but no doubt that also many other stakeholders are contributing to those projects through the means of ICT. And those projects then are cooperating together. There are different working groups in Bridge, one of them being data management working group. It is chaired by Olivier Jeunesse, who will make a presentation later. There are other working groups like regulation or customer engagement. And each of the working groups then produces regularly some reports. Normally the working cycle is annual, so that there are, for each year, there will be new plans and new deliverables will be produced. And obviously, we are in the data management working group. And going closer to the topic of today, so it is to stress that the Horizon 2020 Smart Grid projects have investigated the usage of data exchange solutions, and specifically data exchange platforms and interoperability of those solutions. Which means it's not just about the platform-to-platform interoperability, but we were considering different solutions like bilateral data exchanges. So we even need to ensure the interoperability between those different approaches. The Bridge study on reference architecture makes several recommendations for business process agnostic data exchange reference architecture in the energy domain. But that's not the full story. We also tried to explain and stress that we need to facilitate the cross-sector and also cross-border data exchange on European level in order to ensure free flow of data between any stakeholder and while still respecting the data privacy. So all the presentations will be around these topics. But first, I have the honor to ask the representative from the European Commission, Julia Serra, to take the floor and make some introductory notes. Julia, the floor is yours.
Thank you. I hope you can clearly see me and hear me, and thank you for your introduction. Good morning, everyone. And indeed, everything you mentioned until now is of utmost importance for what we have been doing so far and what actually we plan to do in the near future. Before going into details, this morning I would like first to provide you with a brief overview on actually where we are with the Green Deal, where we are with the climate target plan for 2030, for the Fit for 55 package, and also what is the close link and the synergies that actually we see with another important priority, that is creating a Europe that fits for the digital age. And then in this context, I would like you to, I would like to highlight even more the importance of investigating the use of data exchange, but also to work on interoperability and flexibility solution based on what we have been doing so far. So indeed, what we have been doing also through Horizon 2020, but also what we plan to do. So with that said, I would say let's start from the Green Deal. So somehow to what happened before the COVID-19 era. As you know, the Green Deal aims at transforming the European economy for a sustainable future, at the same time leaving no one behind. This aspect of leaving no one behind is actually at the core of the Green Deal strategy. We have to take care that actually, if we want to create and make this transition happening, everyone goes along with it. And this is, I would say, one of the key elements that actually distinguishes the Green Deal from normal environmental policy that we have been seeing more or less until now. So the first difference is indeed the Green Deal aims at a fair and just transition. And at the same time is an incredibly ambitious plan with all kind of elements in it. It covers finance, it includes research and innovation for the areas that we need to focus on. It's about inclusiveness of citizens, so we really care a lot about having citizens at the center. It considers the geopolitical context, the European Climate Pact, and many other different aspects. So a second very important highlight is the Green Deal is ambitious, and it recognizes the urgency of taking actions on different fields. So first of all, we need to save our ecosystem for future generation. We always mention the importance to the fact that we need a transition that is future-proof. The Green Deal at the same time recognizes on one side the urgency to get to climate neutrality by 2050, and at the same time the urgency to stop the loss of biodiversity and to stop polluting completely. So this is once again another important peculiarity, I would say, of the Green Deal is one single plan, a very ambitious one, for one single ecosystem. So considering the ecosystem as like a single one, instead of having different kind of actions that target different kind of sector. And in this sense, this is also why the Green Deal is what we call a growth strategy. So is our really attempt to create new momentum, but also a chance for us to create and to trigger new dynamics. For this aspect of having this Green Deal as a growth strategy, as covering the entire ecosystem, I will go back to this in a minute, because indeed here is the key point where we see a lot of synergies with other Commission priorities, such as, in fact, all the priorities that are linked to digitalization. Of course, the context we are working now, I mean, back then when we designed the Green Deal, we would have never imagined that something like the COVID-19 would have hit us. So we really had to change, to start to think about changing our way of life, our economy, our society, and somehow being the Green Deal, the growth strategy, this brought us and opened up the chance for us to think about a recovery that can be on one side green and sustainable, and also digital, with once again citizen at the center. Based on this, then the climate target plan for 2030 came in. It's a pretty simple plan. Actually, if we want to achieve carbon neutrality in 2050, we need to reduce our emission by 2030 by 55%. And how do we do that? We need to translate this into legislation, and this is where actually the Fit for 55 package comes in, where actually it's a package that shows pretty clearly that all the sectors have to contribute to make this transition and to happening and to realize our objectives. The Fit for 55 package is actually delivers everything we want to deliver. On one side, it delivers the Paris Agreement. It, of course, also the other countries will play the role they committed to. And of course, it set more ambitious and cost-effective path to achieve climate neutrality in 2050 and stimulate the creation of jobs. So once again, it's really built on a fair and just transition. And of course, we know that actually opportunities never come without challenges. And one of the challenges that we see in this particular period is, of course, the fact that we need a coordinated efforts between member states and what we are doing at the European level. So this, I would say, this is the framework we are currently working in, we are currently operating. And once again, we see very close links and synergies with another important priority for us, that is indeed creating a Europe that actually fits for the digital age. On this, let me say that indeed, as we know, digital technology is changing completely people's lives, and the European digital strategy aims to make this transformation working not only for people, but also for businesses and for our environment. So this is why we can call and we can talk about a twin energy and digital transition. If we want to achieve our objective of carbon neutrality in 2050, if we want to achieve our climate target plan for 2030, then we need to make Europe fit for the digital age. And how do we do that? Actually, we need a better functioning, smart, integrated, interconnected energy system where actually new business models can easily emerge. We need to actually create a market that can be competitive for all the players without, of course, neglecting the importance of the role that we would like consumers and also citizens in a broader perspective to play. So digitalization is indeed a game changer. Has the potential on one side to accelerate even more the shift towards a multidirectional distributed energy system where actually demand sources participate actively in balancing supply at all different scales. Connectivity, of course, permits the linking, the monitoring, the aggregation and control of large numbers of individual energy producing units, and of course, pieces of consuming equipment, ranging from electric vehicles, wind farms, rooftop of solar system. At the same time, we know that these opportunities also brings the attention to the related challenges that are challenges that are I would say specifically related to the energy sector, in particular, for instance, in terms of cybersecurity. So we need to take into account different factors. We need to take into account that all the players of the energy value chain have to be involved, and also the players of the digital value chains have to be considered. And we need to be sure that actually we respect the rights and the privacy of consumers and of citizens that we would like to engage with. So how to make this happen, how to make these twin digital and energy transitions real? Easy data access and data exchange are the key. So are necessary to create a competitive market for energy services that is able to value flexibility and help the integration of renewables in the grid. And of course, balancing requirements for flexibility, demand levels, and the volatility of energy sources is a major and challenging test. Data management is a crucial enabler we need to work on. We need to find concrete solution that can work in terms of managing demand and response, making the right decision to stabilize the electricity grid, for example. And of course, it will be critical for infrastructure. So we need to enable a data-driven energy services platform that works for the market we would like to create. And of course, we need to make this work for citizens. We need to enhance the uptake of digital technologies in the energy sector. We need to address specific challenges like the one for cybersecurity. We need to find a way to lower the energy consumption that is related to ICT. And on this, I would like to mention that luckily we are not starting from scratch. The Clean Energy Package has already set very ambitious regulatory framework when it comes to data protection and to data management and cybersecurity, enables this European data-driven energy services market that, of course, we have to think about how to develop it and how to implement. That, of course, brings forward opportunities for sector integration involving citizens, different players of the value chain, and different kind of sectors. And as Carl mentioned at the beginning, actually, we made a lot of progresses until now through Horizon 2020 projects. We have supported innovation in smart grids, that pilot test and trial the smart network engagement, integration of flexibility that is provided by supply and demand side, and digital markets of the future. Most of the projects that I think we will hear about today, and also actually under the bridge umbrella, are already quite familiar with what we have been doing so far through Horizon 2020. It has been mentioned, UCFlex, Interface, OneNet, and their scope. Of course, now we are facing new challenges. I think that through Horizon 2020, it's really clear the progresses that we made. I see this kind of progress as a sort of reality check. At the beginning, we were focusing on solution for standalone technologies. We are now moving to find a way to address the challenges that are systemic, related to the energy system integration. So what do we need now? We need an interoperable community. We need to facilitate the coordination and alignment of different projects and support interaction between the different initiatives that are happening at European but also national level. We need more interoperability of energy services, data and platforms. We need to develop an energy data space that actually enables access and use of energy data. We need to support the development of this European digital data infrastructure to facilitate the data exchange at all levels of the energy value chain. And in this context, I would say the work that Bridge has been doing so far has been very relevant. Bridge for us has proven really to be a valuable tool to increase, first of all, the collaboration among projects, and actually triggering dynamics and a dialogue that is bringing us ideally to reflect to concrete solution that we can implement to address all these challenges and to enable and develop such integrated and interconnected energy system. We had the Bridge General Assembly beginning of March, and this year General Assembly emphasized that technology development are crucial to achieve our climate and energy objectives, and at the same time, how our energy system needs to change to make this happen. And of course, this work at this level, a lot of work has been done. And actually, one of the points of being here today is also to better understand from this specific working group, the working group on data management, how to follow up on what we discussed during the Bridge General Assembly, but also considering the framework we are currently operating in. So to conclude and to give you an overview on actually what we have been doing and what do we plan to do. Of course, once again, digital technologies and data are creating new opportunities. And of course, I'm also referring to the opportunities of boosting the European competitiveness and innovation and opening new global markets for specific components like ICT or electronics, services, and also help to really disseminate and propagate the European approach to standards, products, and services. Of course, we need to consider critical infrastructures, data privacy and security. How do we address them? How do we address cybersecurity? How do we make this happen considering the rights and the privacy of our consumers and citizens? So we have been taking a series of measures to address this situation. And of course, we would like also to hear from you. What do you think about it? What do you think we are actually missing? What we should focus on that is not really clear at the moment, or actually what we should have under our radar? So first of all, in our European data strategy, we underline the importance of handling and sharing data in accordance with the EU value, meaning respecting privacy and data protection rights, and based on, of course, secure infrastructures and trusted value chain, contributing to the sustainability goals. With the new electricity directive, we explicitly state that actually, independently of the data management model used, member states must put in place transparent, non-discriminatory rules for access to data, and they need to ensure cybersecurity and data protection. So, of course, this is very much in line with the security requirements for smart metering and data communication that indeed the electricity directive support. Of course, we also have to deal with big data technologies. And on these, of course, we also have to ensure the compliance with our GDPR. The Clean Energy Package, once again, lays down specific provision for on cybersecurity for the electricity sector. And to complement these, and at the same time helping member states operationalize all these provisions, of course, we are now working on a network code on cybersecurity and implementing Axon data interoperability. The timeline is not there yet, but we plan to work on it. And last but not least, and I think this is also very much the link between the bridge work and what we have been doing, we are currently working on a digitalization of energy action plan. I would say the purpose of this action plan is indeed making use of all the complementarities between these different activities, taking into account the framework we are operating in, and actually highlighting the challenges that we are now facing. This digitalization of energy action plan is foreseen to be adopted in March 2022, so we really are at an early stage, but it would be indeed quite relevant for us to collaborate with you and to discuss with you how to go about it. The scope of this action plan is indeed to contribute to the development of a sustainable, cyber-secure, transparent, competitive market for digital energy services, ensuring data privacy, supporting investment in digital energy infrastructures. And of course, it focuses also on overcoming the challenges that are specifically related to the energy sector. So it's indeed something that actually can allow us to bring together all the tools, the instruments, the activities that we have been worked on and actually we plan to work on, and try to unblock the potential of such synergies. So this is just to say that indeed this twin and digital transition can only work if we actually collaborate together, if we create synergies, collaboration, and if we have a constant dialogue, exchanges, especially with you. So also, I very much look forward for the discussion of today, because we would really hear from you, okay, what do you think about it? What are we missing? What we should focus on? How do you think you can contribute? What do you think we should focus in terms of action we should implement to make this twin transition happen, but also to really change the way we manage our energy system? How do we develop and implement solutions for data exchange, for interoperability, for flexibility of the energy system? Of course, keeping in mind that actually we need to boost the competitiveness of the European sector in the global market, and at the same time creating a safe, I would say, environment for consumers, citizens, but also for the value chain players. So this is like everything that I wanted to mention for this introduction. And yeah, I mean, we would really appreciate any kind of input you have on this regard, comments, or yeah, concrete proposals. And of course, we are open to discuss. Thank you.
Thank you, Julia. Thank you a lot. I don't see any question now to you, but this is to tell everyone that we can take the questions also later, and all the speakers can hopefully address the questions also later during the course of this webinar. We will move on now. Sharing my screen again, and before I start my presentation on the major outcome of this bridge report on the reference architecture, just let me remind you the agenda. We have, after me, we will have Konstantinos from European Dynamics to present the bridge survey, which was one basis for this reference architecture report. Then we will have a presentation by Eric from EDF, and his core expertise is all around common information model, which is another key element of the reference architecture. And then Olivier from Trialog to present the topic on the asset interoperability. And then in the roundtable session, we have 5 more fantastic speakers: Leslav from PSE, Georg from Giode, Laura from TNO, Pierre from Novatec, and Massimo from engineering. We can take questions and answer them after each individual presentation, but we also can address all the questions in the roundtable session, and I have asked all the individual speakers also to actively take part in the roundtable session. Okay, And there was one general question in the chat now, so it has been asked whether the presentations can be shared. I'm sure at least most of the presentations can be shared after the meeting, but we will let you know. Moving on to the proposal for European Energy Data Exchange Reference Architecture. Here it comes. So it is based on SCAM, the Smart Grid architecture model. I believe many of you know it, and it is one of the basic starting point for many of the Horizon projects as well. SCAM is normally a 3-dimension model, but here we are looking at 1 dimension only. And this is the dimension of the layers, also sometimes called interoperability layers. And there are 5 layers here. We can see business, function, information, communication, and component. And the other scale we have added here on the horizontal bar on top of the screen. You can see electricity domain on one side, other domains on the other side, for example, gas, water, transport, whatever, and then the cross sector in the middle. And this is the idea is to bring together the inputs from individual sectors or domains. Of course, our expertise and objective was the electricity domain. We have and we know more information about that, but we also tried to collect information from other domains. We got some feedback and specifically big thanks to the ICT for water representing water sector. And then in this cross-sector domain, we tried to place the commonalities of different domains. And obviously, as you will see, all the commonalities are related to the data management. So it's quite clear and logic as well. Data is something that can be agnostic to specific domains. And we believe that this is the way to ensure this cross-border interoperability. Okay, to click further, each of the interoperability layers we divided into some sub-layers. And this was our own subjective selection, but we thought it was important. And then for each sub-layer, we provide here some examples only, of course. So for example, on the regulation for the electricity, it's the clean energy package. For the water sector, they are mentioning the WHO recommendations. But there are many things in the cross-sector domain like GDPR, EIDAS, NIS, European Data Strategy, and all the regulations and coming out from that. And for each layer and sub-layer, on the right side, we have also a recommendation to make. On this slide, you will see only like a very short wordings of these recommendations. You can find out a lot more in the report once it's out, but also in the presentations coming up soon. And similar exercise for other layers. We identified relevant associations or even initiatives, and in cross-sector domain specifically, it's something like GaiaX, the IDSA, European Commission, of course, and standard organizations. On the business roles, and focusing on the cross-sector now to just explain some of those acronyms, we have roles like data exchange platform operator, data hub operator, authentication service provider, meter data administrator, etc. On the business processes in the electricity, I guess it's fair to say these are the 3 core business domains for the electricity: grid planning, system operation, and market operation. But we can highlight some further business processes which are relevant for any sector, like things related to data governance, big data, data analytics, security and privacy, etc. On the functional layer, we have some more detailed processes, normally sometimes also referred to as linked to system use cases, as opposed to business layer, where we talk business use cases. So some examples here, but for the cross-sector domain, data collection, data sharing, consent management, etc. So again, very agnostic to the specific business processes. Information layer, we have two sub-layers there. First one is on the core or canonical information models and ontologies like SIM, COSEM, IC 61850 for the electricity sector. You see SARF water for water sector, but there are others which are or might be in the future more above the individual domains. SRF is there already, but here's something I've labeled as SIM plus. So maybe we could extend the SIM in the direction where it could capture some further items not related to maybe very specifically to electricity sector. And specifically what we have in mind on the profile and data model layer is that we might need something which is called here private data exchange model. We have seen some gaps there regarding consent management, for example. On the communication layer refers to data formats. So here we don't recognize anything specific to any domain anyway. For protocols, there are some maybe sector-specific protocols, but also, of course, some generic protocols. On the component layer, you can see 3 sub-layers there. And first, it's mentioning data exchange platforms. It's because the focus of this study was on the platforms. So to learn how the different projects which participated in this study, how they are defining the platforms and how they are using the platforms. Mentioning a few of them here. And for the cross-sector domain, we should look something that also works on cross-sector level. We're not really aware of those platforms today yet. Even if technically the examples here, the EcoSP and S3 could work also for other sectors. Applications sublayer, we have SCADA here, energy management system, SCADA also in water. But for cross-sector, some examples here like big data tools or privacy preserving tools. And finally, hardware, it was not really our focus, or we even concluded that it's not applicable. Okay, with that, I will conclude my intervention. Just try to see if there are any questions to me now. Yeah, there is one question, and I'm putting it beyond SIM. There is a task to integrate it SIM and BIM, and make use of linked data and semantic web technologies. Yeah, it's rather a comment from Chowdar and not a question. So maybe Chowdar later on, I think it's a good topic for our roundtable discussion. Maybe we can even give you the floor and you can elaborate further what kind of task you are having in mind, and you can introduce some initiatives you are aware of. So thank you. That's it then from my side for now. I will come back for the roundtable. Meanwhile, I try to introduce the other speakers. So next will be Konstantinos Kotsalos from European Dynamics, who put a great input and effort into this report. Konstantinos, the floor is yours. You can share.
Hello, Kalle. Thank you very much for the introduction also. Could you please give me the rights to share my screen? Okay. Can you see my full screen?
Yes.
Yes?
Yes.
Okay, good. I hope it works. So hello, everyone. This is Konstantinos Kotsalos from European Dynamics, a part of the R&D team of European Dynamics. And we have been working towards the survey of shaping the EU data exchange reference architecture. So the agenda of my presentation essentially aims to provide you some more light about how we reached to this reference architecture that Kalle provided you a thorough description. So in the very beginning, I'll give you some motivation and an overview about our workflow on the survey of the EU reference architecture. Then some details about the survey, the approach we follow, some analysis of on the survey results, but of course, much more detail are on the report that soon will be public. And then some details about the cross-sector integration, so how we integrated other sectors with the EU reference architecture we proposed, and some final remarks. So some motivation, basically I will repeat some words from that Julia mentioned earlier. So there is a trend lately to make the power systems smarter by installing new solutions and with real technological breakthroughs. But the question is, why do we have to make a grid smarter? This is because the power systems have been designed to operate for a different world. And lately, there are several concerns, European concerns, national also strategic plans to reduce CO2 emissions by installing green technologies in the power system, renewables and generally distributed energy resources along the distribution networks, which can provide much operational flexibility for the operation of the grids. So essentially, we have to exploit this operational flexibility, but this can be done by considering this flexibility as an active part on the operation of the grid. But this needs new tools and new tools by the system operators, new devices, and of course, the digitalization of the power system sector, which can take place by technologies such as interoperable data exchange platforms, which have explored in this task. So the overview of our workflow was essentially to develop a conceptual European data exchange model architecture with several functionalities, data governance functionalities, data access, open source technologies, and look also forward for standardization needs by defining interoperable architectures which can provide the coordination of multiple actors, of course, with a seamless and transparent data exchange among multiple actors, such as the utilities, the system operators, prosumers and consumers, and possibly the interaction with other sectors, as we'll see in the following slides, by ensuring, of course, the privacy and security of the sharing of data among the actors. So in this survey, we have basically explored several other R&D projects, more particularly 11 projects, such as among them Interface, EU6Flex, FlexCree, Gift, Interconnect, Platoon, Synergy, Coordinate, D4 Open, TDX Assist, Balance Plans, and the Renaissance. So essentially, our methodology was in the very first step to explore these projects, identify the common grounds among these projects, and refine these outcomes along with the other workflows of the one from the SIM analysis and the other one from the data exchange role models. And then we had an iteration with cross-sector integration, where we have prepared another survey to contact other sectors. And then all these refinements were leveraged for the consideration of the EU reference architecture. So essentially our survey had this schematic. So we gathered general information about the project-specific questions related to the organizational information and technical information about the interoperable data exchange platforms developed in each project accordingly. And then we have essentially mapped these results. We have mapped these results on the SGAM framework, and then we have also considered the opinion of each R&D projects towards the shaping of EU reference architecture. Going into the results analysis, very briefly, just to mention that this is the phase of implementation of each data exchange platform developed in its explored R&D projects. Just to state that 60% of the participated project was in a preliminary phase, but still have decided about their technologies to be used and rather designated their architecture. So the analysis, the results that we have obtained were quite mature. So as a first result, this is basically related to the standardization of processes in the data exchange platforms. The trend we have identified here, you can see two different colors of bars. The green bars are related to the data governance processes. So there are several processes so most of the projects identified have implemented many processes related to data governance, but not only limited to the data exchange and data collection, but also to the data source and metadata source integration, as well as data users authentication among the different services. This, of course, implies that all the data suppliers that exchange amongst them data between the different players and the system operators create a large number of interfaces. Also, very important to be stressed is that there is great effort related to flexibility processes in the majority of the interoperable data exchange platforms, where the data exchange platforms particularly focus on the integration of demand-side flexibility services and all processes related to the incorporation of this flexibility, such as to integrate this flexibility into retail and wholesale market processes by the calculation of flexibility baseline, flexibility prediction, and other considerations, probably referring to qualification, pre-qualification of this flexibility. So essentially, we have mapped these results of the survey into the interoperability layer of SGAM. So essentially, we have provided multiple questions where they had implications about these interoperability layers. So in the following slide, we can see a comparative analysis where the participants provided us some light on where do they think that they have particularly focused along the implementation of their interoperable data exchange architecture within the SGAM layers. So we essentially see the effort that they have put, as well as where do they think that there is lack of effort in these SGAM interoperability layers. So some key points from this analysis are that the data platforms provide a more comprehensive manner to bundle processes and improve the coordination among utilities by including also other players, such as flexibility players, which imply, of course, the participation of end users, and also market functionalities are integrated within these processes. Yet there should be a neat regulatory framework which implies also the incorporation of multiple associations and the a definition, a proper definition of the actors and their subsequent roles. So roles and actors have to be clearly defined to avoid misinterpretation and overlaps amongst them. In the function layer, the majority of the data exchange platforms mainly act as a framework or middleware for the applications, such as for sharing the access to the relevant parties for the to reach data. So regardless the data models and structures, there is much proposition on the data management efforts and responsibilities without the direct involvement of the users, which implies decentralized also architectures. So also in the functional processes, there is also focus attended on the data source integration and ingestion, but with all the subsequent processes related to data handling and metadata handling, with external information from the DSOs, the balance responsible parties, and balance service parties as well. The implementation of this middleware in many cases takes place via the concept of enterprise service bus. The data exchange platforms in some proposed frameworks is also utilized to unlock and channel information flows related to devices, sensors, users, to accommodate technical aggregation information, forecasters, and the interoperability among these energy and non-energy players. In the information layer, we can see that there is also much effort attended. Probably it's the highest effort attended, where essentially the effort is on the definition of canonical models, not limited to semantic, but also to ontology approaches. In the communication, of course, the definition of a conceptual architecture system focuses much on this interoperability layer, and here we have identified some common ground amongst the projects, such as the common usage of REST APIs over secure HTTP connections, the application of the CIM XML files that have been typically exchanged through AMQP and interfaced via the EchoSP. And of course, the IEC well-known communication standards like the IEC 60870 series, as well as the 61850 IEC standard. In the component layer, what we have identified is that there is commonly posed APIs in order to interconnect multiple external systems and services that can interconnect the data exchange platforms with external systems and services. Moving on the methodological approach, we have essentially identified that most projects worked on the definition of their data exchange platform. They have adopted highly adopted IC standards. Also, the adoption of ICTs, standardized ICTs, the definition of common processes and methodologies. All data exchanges are ensured the GDPR compliance among the data owners and control over their data. Also enabling of free flow of data among several actors. Less used the adoption of the harmonized energy role model, and in other also methodological approaches were related to the implementation of tested framework for the validation of interoperability, and less addressed were the policies and regulation alignment among several parties, and less applied methodological approach related to vendors' engagement. Now, the participants provided also some recommendations about the pillars that they envision to be as the most important for the definition of the reference architecture. And as you can see, they considered open source solution as the most important, the consideration of free flow of data and common consensus, the existence of common consensus among the multiple entities of sharing data and metadata. And then lesser important are the use of repositories and the standardization of the sector, the establishment of EU entity for the interoperability management, alignment of the network codes related to cross-border and national regulatory entities towards the EU standardization. And the lesser important is the deployment of secure blockchains IoT-based solutions. Now, continuing, all participants considered that the definition of EU reference architecture is of great importance. In particular, they stated that it will provide multiple benefits from the enhanced cooperation between actors in the electricity sectors, which also implies the engagement of consumers. And these benefits also are implied due to the improved quality of service and the engagement of consumers. So essentially, all the benefits are supposed to be shared with also the users, providing benefits to them. Benefits also will be based on market parties and their coordination with the facilitation of demand-side flexibility and the integration of distributed energy resources. And also benefits are based on the TSO-DSO coordination via the optimal decision-making amongst these parties, which will bring lower operational costs. Also, the participants stated that benefits will come from the decreased ICT development with the subsequent decreased maintenance cost. Within the energy value chains, the end consumers are meant to be integrated by bringing benefits to them. Yet the definition of a reference architecture is a complex task, according to the participants on the R&D projects, due to the high investments and much effort. So all involved actors should be open-minded with increased coordination amongst them. Also, benefits are meant to come among the technology providers and procurers, which are meant to be incorporated in this implemented act. Now, continuing, the participants were also asked about which is the impact of these different elements on the definition of interoperable reference architecture. And basically, based on the ranking that we did, we've seen that according to the most impact on these elements, the most important barrier is the unwillingness among players to exchange private data and models due to privacy issues. Secondly, second and most important, the limited standards and generally the need for updates of these standards. Thirdly, the vulnerability to cyber attacks. And last, the competition among vendors and technology procurers. Now moving on to the next topic, which was essentially the integration of the cross sector. So essentially, in this methodological step, we look back to the fundamentals and identify of what the electricity sector and the energy sector is comprised of. So the energy sector is comprised of multiple vectors. So it's essentially the electricity, natural gas, district heat utilities, and all these essentially utilities target to operate their grids in an optimal way. In the research community, lately, there is much effort attended on multi-carrier energy systems. So essentially, we have considered the possible cross-vector integration or within the energy sector. Most importantly, we've seen that this is meant to take place because there are multiple dependencies within the sector of energy sector due to seasonality effects and variability effects. So there is an interdependence among these vectors of the energy sector. But also, there is the key feature of all these utilities is the data source integration. So it would be essential to identify if there are interdependencies and look towards this path of essentially exchanging information among these utilities. Also, we have looked towards the integration of other sectors, such as the water sector, where, for instance, we can provide an example that the water sector provides interdependencies with electricity. This can happen due to the fact that the water usage and delivery follows seasonal and weather changes. Additionally, wastewater management is performed by utilizing great amount of energy. So it is essentially to harmonize the development and to the content of the business use case for cross-sector domain integration within the definition of interoperable data exchange platforms, and again, cross-sector and cross-vector integration. To conclude my presentation, now looking back at the reference architecture that Kalle described earlier, we have particularly seen that there is much interest on towards the reference architecture by particularly focusing in this gray zone, which is related to the data sharing. So if we take it from the beginning, essentially the facilitation of regulation with the consideration of the cross-sector and cross-vector integration, the cooperation of all these domains, the harmonization of the energy and non-energy also role models, the harmonization of the business use case, but some light related to the functional processes, all processes that are related to the data collection, data sharing, consent management, data users authentication, and management of data logs. These are of particular importance that should be attended for the towards the definition of a reference architecture with integration of multiple domains. Thank you very much for your attention.
Thank you, Konstantinos. There is one specific, quite technical question. If you go back to your slide on where you had the survey results, the figure of flexibility processes and data processes.
Yes.
Yeah, that one. Yeah, flexibility process and data governance process. The question is simply, what do the numbers represent on the y-axis? I guess it's the percentage, but you can explain the percentage of what?
Yeah, so essentially, okay, we have asked the participants to identify. We have provided a long list of processes, and we have asked the participants to select which of them are integrated, implemented in their data exchange platform. But of course, there was also an option for them to complement standardized processes. So basically here we enlist the most important, but in our report there is also an analysis of all the standardized processes. But here the percentage is the percentage amongst the collected answers.
Basically, the share of projects which stress the importance of that specific process you can see on the x-axis.
In particular, sorry, Khaled, just to complement that, we have in particular 11 projects that reply to our survey. So there were 11 different data exchange platforms with, of course, much common ground amongst them.
Thank you, Konstantinos. So I hope you can rejoin for the roundtable discussion. We before we go to the next presenter, I can confirm, Willem, we can see, or I can see your questions as well. Thanks for the nice words. But let me address the question in the roundtable session. And also there is a question that where can we read the report? So I can confirm what I said in the beginning, that the report is not yet publicly available, but we hope it will be available very soon. And as soon as it is, I believe we can directly send all the people in the audience the link. So let's go to the next presenter, who is Eric Lambert from EDF, and he will educate us on the common information model activities. So Eric, the floor is yours. Thank you.
Good morning, everyone. Okay, so Eric Lambert from EDF, Research and Development Division, and I will present this morning the common information model workflow that we have managed in data model.
I think we should move to the next presentation and come back to Eric later. We cannot hear you very well, really.
And distribution.
So maybe the host can disconnect Eric, and we can move on. If okay, Olivier, to you. But we'll take first your presentation and then try to fix meanwhile Eric's audio and come back to that presentation.
Okay, we can do that.
Yeah. Okay. Please give floor to Olivier Genest from Charlotte.
Okay, perfect. So what I would like to talk about today is about the work we did on enabling the interoperability of flexibility assets. So it's also in the scope of Bridge into data management working group, and we specifically focus on some of the layers and for flexibility. So it's based on the objectives that we defined during the last General Assembly in 2020, in which we say that we need to provide some recommendations, some best practices, and possibly tools for interoperability, focusing on a function layer, so it means system use case and services, and also on the information layer about semantic interoperability in data models. So for that, we would like to cover the full flexibility chain. So not only how we'll activate the flexibility, but starting from the request, the bidding, the negotiation, and finally down to the activation and settlement of flexibility. So as for all these kind of Bridge activities, we rely on the input that we have from Bridge project, but this time we want to define a kind of stable methodology in which we can update each time we have new project. So each year we have maybe like between 5 and 10 new projects that are joining Bridge. So we need to include them each time, so we can update the result that we want to promote. So the approach that we define a methodology, and that is based on a reference framework. So if I show the diagram, here you can see this analysis methodology, which is the core of what we define, and it is based on a reference framework that are with details that define some generic business processes and some function and interfaces, and then it helps to to process the input that we'll have from project about the architecture, which solution they implemented, and if they have any feedback about how standards are fulfilling their needs. And the outcomes that we have will be mostly a map of standard or catalog, and also some gaps that we can see we can fulfill. So if we look at this reference framework, the general principle is that we define some generic business processes. So you can see it on the left, and it's similar to a business process model notation. So you see that we have several business roles, and in fact they have some interaction with these arrows, and they are doing something in these boxes. So each of these boxes is what we call a function, which is described with a purpose, some input and output, and also some possible external interactions that are required that will not be directly with the business role here. For example, for the system operator to evaluate its need for flexibility, it will gather some information about the weather or DER forecast, and these are the external data, but finally there will be interaction between the system operator here and the market operator. So we have these 4 business roles. So system operator means either the DSO or the TSO. The BRP is for the balance responsibility party, and we have this market operator and aggregator and the prosumers that will provide some flexibility. And so for each of these arrows, we also define what we call interface, and so which roles are involved, and also what kind of data is exchanged. So it helps us to see what are the needs for data exchange in each of these cases. And so how is this used? Based on the SGAM smart grid architecture model, each project is defining its use cases and how its system is designed. And we use the information from the SGAM function layer and the SGAM information layer, because we say these are the 2 focus for us. And for this function layer, all these functions are mapped to this generic business process, to the boxes that we have here. And we do the same with the information layer. So all of this data exchange depicted here will be connected to the interaction that we have in the generic business process. So as you see, it allows to compare several implementation from different projects with a common ground that will be this generic business process that we use as a reference. And then we are able to compare how each of these interaction in orange, for example, are implemented, but also how each of these boxes, each of these functions in blue are implemented by different projects. So if I look at the 3 generic business processes that we defined so far, the first one is about the flexibility for system operators through an open market. So the idea is that we have the prosumer that can assess how much flexibility it can offer, and then can provide this information to the aggregator, who will aggregate this information and finally be able to place some selling offer to the market. And on the other side, the SO, in this case, who will be the one requiring flexibility, can define the flexibility request, and depending on the market model, can directly go to the market to push this flexibility request, or can go through the BRP that will itself place a buying offer. So we have this market operator that will operate the market and define which flexibility is selected. And finally, this information is shared with all the parties. So the aggregator will disaggregate the offer and be able to send some or to process some activation for each of the concerned prosumers. On the other side, the DSO will just process the market result, and at the end, we'll have a final phase in which we'll settle the flexibility. So that's the first case, but that can be mapped for some of the project, but not all of them. So that's why we also define what we call the flexibility for system operators via prior bilateral agreement. So the idea here is that we don't have any live market, we don't have any market operators that will directly look at the requests and the offers, but instead we have the system operator that will establish a direct bilateral agreement with the aggregator. And when this is done in this preliminary phase, we can go into the operational phase, in which when the system operator will require some flexibility, it can directly send some request to the aggregator with which the bilateral agreement was signed. And then this aggregator can process a request, provide some information, maybe update about the amount of flexibility that can be provided, and then we'll process the flexibility schedule. And we still have this settlement at the end. And finally, we have this third one, which is about the case we provide flexibility for the BRP, flexible for portfolio optimization. So in this case, the prosumer will still evaluate its flexibility and provide this information to the aggregator that will place the sending offer. And the BRP on its side will also evaluate which flexibility he would like to buy and place this buying offer. The main difference with the generic business process one is that in this case, we need to make sure that the choice of flexibility will not affect the distribution or the transmission network. And so for this, when we are doing this market operation, there is a connection with the system operator, so it can validate that the chosen solution will not break something else. And finally, once this is done, we have the same approach with this process of the schedule of the process, and finally settlement. And so what we see also is that with these boxes, sometimes they are the same between several generic business processes, which means that we can compare them, whatever to which generic business process they are mapped to. So based on this framework, we applied this methodology to 4 projects, and in particular 7 use cases. So you can see the name of the project here. So it's just some example. Of course, it is not fully providing a large view of what is available in Bridge, but at least it helped to see if the system works and how we can already achieve some first results. So we did 5 analyses, and I will go through each of them in the next slide. So the first one is that we looked at each of these interfaces and which solution or standard were implemented by the project. And so, for example, we see that for this interface P1 to A1, we have a list of existing standards that were implemented, and also we provide the occurrence, so how many projects or how many use cases claimed that they were using this solution to implement this interface. Also, we are highlighting how many project claims either internal or proprietary solution. So it helps to see that maybe in some cases the available solution do not fulfill here, or that it's mostly internal interface. So you see the purpose of this catalog is to provide a view of which solutions are relevant for each interface, and also to identify if there is a competition or if one of these standards is the most used, and also if there is a need to consider it specifically because there is some internal or proprietary solution. So the second outcome that we have, second analysis we do, is that we list all the extension or modification or deviations that were highlighted by the project for each of the standards. So it helps to see that maybe something is missing, like when we have SIM here. Of course, Eric could provide a good feedback on this. Some projects said, okay, I was missing this class that I had to add, and someone else added something else. And so this has 2 purposes. The first one is that we can provide this information to the SIM development in the standardization bodies, so they can integrate this need if they think it is relevant. And also it allows to enable the reusability of what has been done by previous project, because if a new project wants to, for example, to add some information about meter reading into this SIM, it can directly rely on what was done by GIFT, and this could be made available on a kind of repository. The third analysis that we did was to look at the gaps that were raised by the project for each of these interfaces. So, for example, saying that there is no existing standard for this interface, or that the existing standard do not fully cover the needs. So, of course, this has to be checked with also what we have in 1, because maybe the catalog of standard will help to show that there are some solutions existing and there is no gap on this case. So the fourth analysis was about the function. So we wanted to see how this generic business process function were implemented into the different projects. And so for that, so far we only looked at function names, because there are not so much function focusing, a standard focusing on functions. And so for this, we just listed what are the name of the function in each project, and so it helps to see how this was managed, and also to see if some functions are very often skipped. And if it's the case, it means that we need to think if it is still relevant to keep it in the generic business process or not. And so the fifth one is about the actors, and we're doing that for each generic business process to look at the name of the actors that we have in the different project and map them with a business role. So it gives some information about how these business roles are implemented, if it's only one or several actors. And also it will help to identify what are the existing solutions that are provided by a project for each of these roles and the resulting actors. So as you've seen, we've done 5 different analyses, and of course, it's largely incomplete because we only looked at 4 projects and 7 use cases, but we have 56 active projects in each country, so really we can have much more input that we can use to feed this methodology. So we have this catalog of standards that is largely incomplete, but in the future, when we have more projects, it can very be useful to have a quick view on what are the existing standards to implement some business processes. Also, we already identified some extensions, so we are seeing inside Bridge how we can build a user group, or at least some liaison with the standardization bodies, so we can improve the existing standard or extend them. Also, we identified some gaps, but as I said, we need to check they are consistent with the catalog. And finally, we have some information about the same function and system actors, but they are not significant enough so far because we have only 4 projects. So what are the conclusions of this overall topic of interoperability of flexibility asset? Is that we have defined this methodology, and we have defined a reference framework that is based on 3 first generic business processes that are a common denominator between the use cases from different projects. And so this is very useful, and it helps to generate some outcome, one of them being this catalog of standards, but also listing some gaps and possible extension, and also this mapping of system implementation with the business roles and use cases. So what will we do in 2021 is that we first want to publish our result on the e-read knowledge platform that is being developed by the Pantera project and will be provided together with the GRC and in connection with Spring, the project that is managing Bridge and EdipsNet. The second one is that we want to collect input from more Bridge project. So we'll ask the Bridge project to provide some contribution, and so we can update our analysis. And we'll do that probably when the project will have already defined their use cases. So between months 12 or months 18 of the project, we can collect this information and analyze them. Also, we need to look at this reference frameworks and these 3 generic business processes. Maybe we need to update them because we are missing some function or some interaction, but also we may need to add some new generic business processes in case we have some use cases that are not covered by these generic business processes. And finally, we need to collaborate with the standardization bodies to enable Bridge to provide some feedback on the standard and our experience. And probably this will be done in 2 ways. The first one being having a user group, and Eric maybe will mention it also, in which we can, within Bridge, already share some information and converge on what and how it should be done. And also, we could directly have some liaison with standardization bodies, so we can provide some inputs to the standardization document and through the Bridge participants that are already active in the standardization bodies. So that's it. That's what I wanted to explain today, and showing how, if we look into the function and information layer in particular, and mapping with generic business processes, we are able to define tools that will help to reach interoperability of flexibility assets.
Thank you, Olivier. I don't see any specific question now to you, but there will be later. For me, what you just presented, it very well links to the reference architecture exercise, because it's a way, the methodology you're providing, it's a way how to implement the reference architecture, at least on function layer and on part of the information layer. So it gets together very well for me. So thank you, Olivier, once again. We go back now to Eric.
Good morning, everyone. Sorry for this technical issue. Hopefully it will be better now, having Calais showing my slides. So I am Eric Lambert from EDF R&D division. I am member of several standardization committees, either at the European level and at the international level, at the IEC level. In Bridge, I was leading this common information model workflow, and I will present briefly what are the outcomes of this workflow. So Calais, you can go to the next slide. As it has been mentioned by Calais Konstantinos, we are leveraging the smart grid architecture model in this European Energy Data Exchange Reference Architecture. As you know, the SGAM has been defined during the M490 Smart Grid mandate several years ago, and I will focus here on this presentation on the information layer of the SGAM, where you find different data models. Next slide, please. So just a reminder, IEC has defined core information models. Among them, so we have the 6150 data model, which is supporting substation automation systems and distribution automation systems. We have also the COSEM data model, which is supporting smart metering systems. And as you know, in the former M441 smart metering mandate, it was recommended in Europe to leverage and to use a COSEM data model for our smart metering systems. And the third data model is a common information model. And as you can see on this GAM, it spans over generation, transmission, distribution, DR, and customer premises domains. And it starts at the operational layer of the SGAM, where you find remote control systems. It can be used at the enterprise level up to the market level. What has to be pointed out is that we have harmonization standard documents between these three data models. And it's really important to have these harmonization documents. Next slide, please. In the 2020 parallel session of Bridge, we presented the methodology supporting the common information model usage. We based our presentation on a TDX Assist project, which was defining several use cases between TSOs, DSOs, and other market participants. And as you can see on this slide, we have the information model SIM, from which, from this information model and based on use case analysis and business object definition, we can derive business objects, new business objects, or we can also use and reuse, consolidate existing profiles which have already been defined by IEC. And for instance, like the CGMES standard, the Common Grid Model Exchange Standard, which is supporting some European regulation. And that's what we did in TDX Assist. And eventually, we can raise issues towards standardization bodies in order to consolidate the common information model or to extend an existing profile. So this is the main topic regarding the methodology around the common information model and profile definition based on business object analysis and use case definition. Another input to this work is the fact, and it has been presented before by Olivier, the interactions between energy domains. So in IEC, we have also leveraged the SGAM, and we have extended the SGAM to other energy domains. And it is this figures is extracted from IEC 63200 document. And what you can see that we have different energy domains where we will have energy flows, and we will have also to manage information flows between these energy domains. So, and we can reuse the smart grid architecture model approach in order to bridge these energy domains. So we ended up with several recommendations in this SIM workflow. We have a strong methodology based on use case definition, and if you can remind also the smart grid the smart grid mandate M490, where we had a working group on sustainable processes, and this use case approach has been standardized in IEC in 62913-1 documents, where we define what is a business use case, what is a system use case, how we can derive profiles from information models. And our first recommendation is to define a canonical data model facilitating cross-sector data exchanges, for instance, by extending common information model and or integrating other sectors' canonical data models with SIM. So in this also scope, we should also study the benefit to use ontologies to support cross-sector interactions. So this is the first recommendations. The second one is, as I exposed the methodology to derive profiles from business object definition based on the use case development. It's a very robust methodology. So we should develop cross-sector data models and this notion of profiles between cross-sector based on use case definition. And as you can see also, we have documents which are supporting this profiling methodology, which have been defined at the IEC level. And we can extend this profile methodology to our 3 core data models, but also to these cross-sector data models. So another outcome of this SIM workflow is the fact that we need to promote reusability among European projects. So in this SIM workflow, we conducted a survey among different bridge-related projects. What were their expectations regarding SIM? Did they have already profiled the common information model? One of the outcome is the fact that projects are at different stages, and we need to promote knowledge about SIM. We need to manage SIM repositories. So this is the third recommendation, is to set up and manage SIM repository for bridge projects and beyond in order to improve reusability and not to redefine the wheel, reinvent the wheel each time we need to work on a new use case. So, and it is also related to the fact that in Bridge, we also set up a use case repository to be shared among different Bridge participating projects. Next slide, please. So this is on this slide to illustrate the different kind of SIM repositories. On the left part of the slide, we can have very basic SIM repository spreadsheets where we identify use cases and the business objects which have been defined in these use cases. And if these business objects have been profiled using SIM, reusing an existing SIM profile or creating a new SIM profile. But we can also manage more complicated or more useful kind of SIM repository. As you know, SIM is managed in UML, using the Unified Modeling Language. We use a UML framework, and we can manage these SIM repositories using the UML repositories, and it will be consistent with the fact that SIM is using UML and using UML frameworks. So on the right part of the slide, you can see that from UML repositories, we can export business objects that have been defined in use cases, also managed in UML. And we have a consistent framework to manage use cases, business objects associated to these use cases, information models like SIM, 615, COSM, and other data models, and also associated profiles, everything in a single repository. And we also can manage versions of these different data models and profiles. So what about supporting this complex system of systems supported by European Energy Data Exchange Reference Architecture? We need to, as I mentioned, educate users. We need to get user feedback from European projects. We need, as it has been also mentioned by Olivier, to conduct a standard gap analysis and to manage governance. So our recommendations also are aligned with what we are doing at the European level, that will be illustrated on the next slide. So it's just a reminder of what we are doing at the standardization level, at the European level. We have set up a coordination group on smart energy grids, and there is also a coordination group on the smart metering systems. And what we've done these last few years is that we have analyzed the European regulation in a working group of CG-SEG. And based on this analysis, we classified gaps in standards, and we identified if these gaps had a high-level priority, and some of these gaps have to be solved either at the European level, or eventually they are brought to IEC in order to feed documents at the IEC level. These two documents are very important. The first one is 63-199, which lists the top priority standards development status in the domain of smart energy. So it helps to IEC technical committees to solve these gaps, and it also serves to complement the 63-097 document, which is the Smart Grid Standardization Roadmap, which is a freely available document, and which is very important because it lists all the use cases, standards associated to each smart energy system which are supporting our energy transition. So as you can see on this slide, we conducted this work at the European level in Senseneketsi, and we have a close relationship with IEC System Committee Smart Energy. So we can go to the next slide. Another input which is really important is the fact that we are building for several years this interconnected electricity market. And here I leverage an ENSOE figure. On the left part of the slide, you have these European grid codes and guidelines, the connection codes, the market and trading guidelines, and the operational codes. And as you can see, for 10 years at least, we are supporting this regulation using the SIM. So the SIM for market, which is supported by IEC 62325 series, is supporting the market and trading guidelines. We have also the CGMES, the Common Grid Model Exchange Standard, which is supporting the operational codes. And as you can see, with the Clean Energy Package, we have new use cases related to TSO, DSO, significant grid users use cases. We have to support retail market participation, and we will also leverage a common information model for these new use cases. It's really important regarding the common information model to have continuous training and knowledge sharing among projects funded by the European Commission. It's not only the SIM. We need to involve also other smart energy standards. So our proposal is to set up a European SIM user group and eventually a smart energy standard user group in order to consolidate our knowledge among research centers, European academics, standardization bodies at the European level. So this is one of the outcome of our workflow. And we can go to the next slide. This to illustrate the ecosystem between standardization bodies at the international level. You find the ISO, IEC, ITU, the mirroring organization at the European level, Sense and EC, the links between these standardization bodies and user groups, and the idea to have a European user group, maybe still in bridge domain with a close relationship with JRC and also technology platforms which are also providing results which can be leveraged. And it's really important to have this value chain between these user groups and standard organizations, which is also a recommendation concerning to set up a strategy to disseminate advantages and benefits that SIM usage provides, as well to develop a systematic approach in provision of education and consulting to all interested parties across Europe. Yeah, it's really important to have academics, students knowledgeable about SIM, to have data sets modeled in SIM, and it will facilitate compliance testing and interoperability test that we need to set up on a regular basis at the European level. This is the final slide, and it's just to stress the point that we are defining standards in different standard development organizations, but at the IEC level, we have also stressed the fact that we are developing now what we call code components. So standards are not anymore paper documents. You will buy a paper document, but you will also have a code component associated to this standard document. So for instance, when I was referring to CGMES, CGMES is also a profile that you can reuse automatically in a platform. So it's really important to make SIM UML models and associated profiles available in order to be used by the community and following a clear procedures with IEC and associated standard organizations. Thank you for your attention, and I can answer some questions. Thank you, Kelly. Thank you.
Thank you, Eric. There is one question to you, I see. So it says, currently SIM steps on RDF XML and not on any linked data principles. And in brackets, entities don't have any permanent URLs. Should this be fixed? Did you get the question?
I didn't get the question, but okay, it seems to be a technical question, so that's why we recommend to set up this kind of user group regarding technical issues regarding SIM. I wanted also to mention that in Europe we are lucky enough to have an ENSOE SIM expert group. And when we worked in several European projects, we had the chance to have ENSOE participating in this project, and it facilitates the usage of SIM when you have experts from ENSOE. But we need also to figure out how DSOs also will manage SIM in the future. Are they going to set up SIM expert groups inside European DSOs associations? We have also to address this kind of questions. And more generally, it's not only the SIM, it's broader than SIM. It's 61850, COSEM, and other smart energy standards.
Thank you. So if there is, Vladimir, if you need any follow-up clarification, we can come back to it in the roundtable session. Until then, big thanks to Eric, and we go to the roundtable session now. Each speaker has a chance to either introduce herself, himself, and the main ideas the person has. So I give a few minutes to each of the presenters. I know that all of you probably also have a few slides, very few slides. We will start with Lesław Winiarski from PSC, the Polish TSO part here, I guess, representing ENTSO-E in this webinar. So Lesław, the floor is yours.
Thank you very much. Good morning to everybody. So my name is Lesław Winiarski. As Kale said, I am an employee of Polish Transmission System Operator, but I'm also a member of ENTSO-E SIM expert group, which works on developing electronic data interchange standards for European electricity market. Most of this was until now focused on the wholesale market, but as we already heard during this seminar, the market is developing rapidly, and a lot of new players will come very soon to the electricity market, especially concerning renewable energy sources or distributed energy sources. So we'll have more and more players, and also probably we'll need more standards for involving these parties to the market. I just wanted to present a few information about the role model, which is which could be treated as one of reference model. If we look at the interoperability governance model, so we can see that we can see some layers of interoperability. So the legal layer is probably easy in the European member states because we base on the same regulation and policies. We've got also this organizational interoperability, which is defined by the roles and the responsibilities, but also about the task or services provided by these roles, and the business processes, which were also described and presented during this seminar. The other layers are the semantic interoperability, so the information model, which was presented just before, the SIM as an example of the reference model of this information model, and of course the technical interoperability, which allows for exchanging the data and define some formats and protocols. And for all these layers, we can have some reference models, and this seminar or presents just some examples of the reference models. I would even say the most commonly used reference model for this information exchange, and this is surely supporting the interoperability and harmonization of data exchange on the European electricity market. What I wanted to say as an introduction to this roundtable is presentation of harmonized electricity role model, which we could see in many examples already during this seminar, because there were presented the roles which are taking part in business processes or in business use cases. But what is it, the harmonized electricity model? It's the model developed by ENTSO-E, EBIX, and EFET. And for the moment, I think it's the most recognized reference models for roles on the European electricity market. We could see in one of the presentations that about 50% of the responders are recognizing a harmonized electricity role model, but it also means that 50% is not recognizing it very well. And maybe it's a good point for a discussion. Why is it so? I can say also that harmonized role model, the newest version, which was published last year, covers the roles used or defined in network codes, which was drafted by ENTSO-E with the guidance from the Agency for Cooperation of Energy Regulators. And it also covers other roles identified as relevant for information exchange on the European electricity market. And the fact that the roles from the latest role model are based on network codes means that there are more standardized and really or strictly linked to the legal documents or the legal level of the harmonization. What is it used for? We could already see that these roles are used to design processes and use cases for data exchange on European electricity market. And such set of implementation guides describing data exchange using the roles from this harmonized electricity role model has been already developed by ENTSO-E, and it was presented by Eric with a set of such implementing guides. That the standards for electronic data exchange is already available, and also at ENTSO-E, and it could be found on ENTSO-E website. What are the roles? The roles are describing the common responsibilities of electricity market required to allow for cross-border or cross-sector data exchange between the interested parties. These parties can play specific roles in the information exchange, and the common set of roles, which is for example harmonized role model, allows for harmonized data exchange regardless the technical architecture for the data exchange, because it is of course the layer above the technical interoperability. Just to give some imagination what are the roles and how they are defined in the harmonized electricity role model, I provided a few maybe most recognized roles like system operator, grid access provider, party connected to the grid, and balance responsible party. So we can see that the definition of these roles describes the responsibility of the role on the electricity market, but the responsibility concerning the information exchange. And that is all from my side for the introduction. And the question for myself is how to involve the other 50% to be engaged in the development of the harmonized electricity role model. I could also add that this role model is not yet covering the, I would say, new parts of the market, like the flexibility market, mainly because, at least in my opinion, this is just developing, as is not was not yet enough major to be covered by this harmonized electricity role model. And of course, another part of the story is that it was designed by the TSOs and some DSOs engaged in this electronic data interchange, and was not yet supported by the parties playing, for example, of the flexibility market, which is the market for distributed energy resources mainly, and will provide the new parties to the electricity market. Thank you very much.
Thank you, Leslav. Yeah, please keep your own question in mind. We can come back to it then later in the discussion. Second, I think that the question is quite towards the DSOs as well. So the next speaker is Georg Hartner. You have many hats on, like being in Austrian Energy Association. I see the slides here, but also representing GEODE, which is one of the 4 European DSO associations. Please, Georg, the floor is yours.
Thank you, Kelly. Today, I want to show you something about our work in EU Smart Grids Task Force Expert Group 1 for data interoperability. At the moment, we are working on a series of implementing acts to establish interoperability of energy services within the EU, as demanded by several articles in Regulation EU 2019/44 in the Clean Energy Package. We are, as I said, we are working on a series of implementing acts, which means that we will go use case by use case. We start with data sharing, data access. Then we are dealing with distributed flexibility, and then other services like billing, supply, switching, and so on. And as we want to define a consistent interoperability approach across these use case families, we are creating a general interoperability approach first, together with the provisions for data access. We hope that we will have the first two implementing acts ready by the middle of this year, and that they can go through comitology until beginning of next year. Now, we are using data access as the role model for the general provisions as well. So if we talk about data access, which use cases are we talking about? We are dealing with data access to a main meter, not about sub-meters. Article 20 demands making available near real-time data directly from the meter through an interface, and we are planning to provide a reference model for the access to the main meter. So that is near real-time directly from the meter use case family. And then if we look at the usual data flow from a smart meter, data would go through a meter data collector, usually the DSO, then to a meter data responsible, following the harmonized electricity market role model, who would validate and store the data. Also usually the DSO, but also this can be done by a number of other national actors. And then the data flows to meter data administrator, which can be either the DSO, the TSO, a dedicated entity, and that meter data administrator is responsible to store and manage that data and make it available to other actors. Established actors can be suppliers, regulators, and other parties. And what is mandated by Article 23 is that customers can also access the data that is stored about them. That's a use case that we call download my data. And then it's also mandated that this data is also shareable with eligible parties, new players that need that data. So we're talking about the use cases of share my data. This consent for data sharing may also be revoked, and also the eligible party may terminate the service, and then also certain things need to happen. Data transfer is always done from the meter data administrator, and when we're talking about validated historical consumption data, that's the term for these use case families. Now, we are working on implementing it for interoperability, and we have a number of issues to solve. These processes that I showed you in the previous slide, they are organized very diversely in many member states. So we have countries like Estonia, Finland, Denmark, or Norway. We're running national data hubs where data is copied to these hubs, and they make the data available. They run the processes. And we have decentralized environments like Austria, Germany, France, or Spain, where data stays at the DSO as a metadata administrator. And then you have hybrid scenarios. So data management architectures are quite diverse, and we needed to find an approach that would allow for all of these national practices. Then we have a different implementation degree in member states. Of course, there is a number of countries that are acting as front runners, that are very far, and countries that are a bit slower with their implementation. Then we needed to find a way to express these reference models, to find a way to express these provisions. It's not always feasible to use the technical standards. We need to find a balance with what is needed in a legal text and what is needed by a standard. And we needed to achieve comparability. We did the exercise quite several times to show how things are being done in different countries. Very hard to get an overview, even if countries are talking the same language. That's also a goal of our work here, to achieve that comparability before we can improve things. And of course, it's a challenge to find the right level of between just demanding like documentation and be more prescriptive to allow for more interoperability. Then how do we work with reference models? Then we see, we said that we have a primary legislation, which is Regulation EU 2019-944, which leads to the creation of implementing acts, and we're working on these things. And we are aware that not all of the things that needs to be done to establish interoperability can be expressed in a legal act. There are a lot of things that require more flexibility and ongoing work, and these things are outsourced to an EU competent authority, which we don't know yet who this or which organization will be that competent authority. The implementing acts will contain a reference model, and for us, a reference model contains of a process model, which describes process steps as information exchange between the roles in the role model, using information objects and attributes in the information model. And if we look at things over time, like we want to ensure for consistency, so we are aiming towards roles or role descriptions that are consistent between the use cases for data sharing, demand response, and others. So we are rather trying to establish a role model and an information model that is valid for all of these processes, have different implementing acts for these specific use case families, and they should contain the process model then. And what would happen when an implementing act is published is that here it would be like put into force by the European Commission, and we have an EU competent authority who would take the reference model in the Act and provide guidelines and mappings of the national practices, hand that over to member state authorities, who would then map the national practices towards that model and publish these mappings on a single source and make them available to all. Of course, this would just close the information gap, make it accessible to get to know how things work in which country. But for the end, for the technical interoperability, you would need technical reference model standards, and but they are not subject to the legal acts. Thank you.
Thank you, Georg. We move on to the next speakers, and I'm happy to say that the next two roundtable speakers are rather not from the electricity domain, so we will have a bit also the outsider view, and this is what we are here for, to talk about the cross-sector approach. So first, Laura Daniele from TNO, please go ahead.
Okay, hello everyone. Can you hear me now?
Yes.
Yeah, good morning, well, probably good afternoon in the meantime. And my name is Laura Daniele, as I mentioned, and thank you very much for this invitation. Indeed, I'm a little bit an outsider because my domain is not specifically energy domain, electricity market, and everything that has been discussed today. I come more from an IoT perspective. And so what I have a few slides, and mainly also for reference for you later. I will probably skip some, but at least then you have a kind of a story to follow if you want to look at these slides later. Okay, so okay, now it's okay. So this is about me. Sorry for not using the video. I think I don't have a very good connection today, so but this is at least me. You can see me here. I work for TNO, the Netherlands Organization for Applied Scientific Research, where I am a senior scientist in the area of ontology engineering and semantic interoperability. So, well, TNO is basically the largest in that independent research organization in the Netherlands, and we act as intermediary between the research, academic research, and industry. Well, I personally, as I mentioned, work in the area of semantic interoperability. So when we looked today several times at the different levels of interoperability, my area of expertise is the one that goes into the semantic interoperability, informational interoperability, on top of the usual technical interoperability of the data exchange. And so what I do, I have some roles, at least in standardization, where I am active in ETSI, the European Telecommunication Standardization Industry, where I am, I was one of the first creators and still involved in the evolution of the SAREF, Smart Applications Reference Ontology series of specifications of ETSI. In a moment, I will tell you a little bit more about that. Anyways, also when I look today at the reference architectures and all the level at the references to the ESCA model, I saw several references also to SAREF. So it's not totally new to you, I assume. And therefore, I also do serve as expert, as I mentioned, in ETSI, and specifically in the Smart M2M Technical Committee, where we actually do the specifications of SAREF, and some other roles like in the AIUTI, the Alliance for the Internet, for the Internet of Things. I'm also leading together with Martin Bauer, the Semantic Interoperability Group. So at the end, it's clear that my focus is on the data exchange, but on the semantic, adding the semantic part, the semantic interoperability to it. And another thing that I want to mention is that also today was a number of projects that under the umbrella of the Bridge Initiative were mentioned, and one of them is the H2020 Interconnect large-scale pilot, where I am also heavily involved in there, and I will say a few things today of what are the challenges and some insights that can be interesting for this roundtable. The interesting part of Interconnect is that it connects 3 domains, which are the smart homes, buildings, and grids. So it's quite interesting, the combination of these different domains all together. Having said that, I mentioned SAREF, so I will not tell you what's in this model in details, but just to show you that from an IoT perspective, it's all based on the concept of a device So devices that can be used and exposed and can be described in terms of their measurements and property that they measure, where these properties could be also, for example, power, energy, but also something that is not related to the energy domain. It could be any other things, could be temperatures, it could be speed, it could be any other thing, of course, depending on what we're measuring. And yeah, then there are functions, devices can have functions. You can switch on and off lights, washing machines, or heating and things like that. Just to give you a quick idea of what SAREF is. But SAREF is more, because what I showed you is kind of the reference, the core model for the IoT, which says, well, there are those devices in any domain, but then there are some extensions in different domains. So we go into the details of certain devices for certain domains. And of course, for the audience that we have today, one extension very important is the SAREF for energy extension, which is the one for the energy domain. I will not show anything about that, but just consider that there are a few slides in this presentation if later on you want to see more what's in there and have some references to that. Therefore, SAREF is an ontology with extensions for different domains. And it's a series of technical specifications, as I mentioned, published by ETSI. These here are a few pointers to the specifications, and there are more on the website SAREF portal. This one on saref.etsi.org. You can find all the information about this. And there is also a repository, so it's also a collaborative project, SAREF, because of course, there are the experts, we are the experts, but on SAREF within ETSI. But there is also a community of people that are interested in SAREF and also interested in probably submitting contributions and so forth. So there is also a portal with a repository for developers that want to contribute to SAREF. Of course, these contributions, if done, they still have to go via the standardization process, approval, and so on, if we want to bring them into the current specifications. But this is really a way to open up to the world of participants, of users of this framework of ontologies, a way for them to contribute to the whole process. And that's it. Then only thing I want to say is that then there is the Interconnect project, which is a large scale pilot, and there are a few slides about Interconnect. And the interesting thing, as I mentioned before, is that connects the different domains, smart homes. So we are more in the IoT part with the smart buildings and the smart grids. So it's a very big coverage of data exchange, of type of information, of a lot of actors, of course, involved in that. And it's very challenging, and there are some impacts, of course, that we expect to achieve. I'll leave this here for you if you want to read it later. But of course, what we do here, being a large-scale pilot, it's because there are several pilots in Europe, which are 7, and you can see here which one of these pilots are, and all of them will implement, so we will create interoperability using the same concepts and also this reference ontology on top of it, which is SAREF at the semantic layer. And of course, so keeping what are the infrastructure platforms, everything that is existing already, and just putting on top of that our ontology reference model, only for the communication of things that want to become interoperable. All the other details will stay as they are, but we try to make interoperable only the part and the use cases and the communication that is important to go via an interoperability layer, a semantic interoperability layer. I think I think that's the most important slide at the end, although of course there are some other questions by listening of today's presentations and observations of all the speakers and panelists. So from the ontology point of view, it's really challenging combining these different domains. And in general, I think this holds for any, well, data model and when you want to make them interoperable. So these domains we're talking about in this project are already mature domains, and they evolved in parallel in the past. They had different requirements, communities, different standards, standardization bodies, different architectures. So combining of these is, of course, it's a huge challenge that we need to face now. For example, when creating reference architecture for interconnect, there was the challenge, of course, to take energy, smart grid architectures, take into account then the IoT architecture, putting together semantic components that would allow to also use the ontologies in this whole setting. So, of course, the challenges are quite a lot there, but that's what makes it also interesting and what will really bring us one step ahead once we have the results on this. Other observation is that, well, ontologies are really something not yet understood in practice, at least. So there is an understanding of how ontologies can be used as a reference model to facilitate the communication, let's say, but using them in practice is very difficult. So in these pilots that you have seen, we are facing the fact that, of course, it's difficult to bring, to deploy and bring this little bit more abstract concept of the ontologies and the data model into the implementation. And then other observation that I would like to put here in the panel as full of thoughts is that one of the models, the parts of SAREF that, of course, will also be a main result of interconnect is an improved new version, at least, of SAREF for energy, which will also cover flexibility. And we have seen how many stakeholders. So the first version, SAREF for energy, was developed together with the EBAS and Energy Atom associations to make interoperable their data models. And it's very much in this moment still based also on the SPINE standard specification from EBAS and Energy Atom. But of course, we've seen that we have, while the interfaces is true, we've seen a lot of things, and we know that there are a lot of models, actor, and the reference architecture for the energy domain is broad with several actors. So the point is now to cover flexibility in a more broader sense and see where we can go and with more stakeholders. And this is, of course, very, very challenging because more consensus, more stakeholders need to be brought together. But this will definitely make this result much better, because then we will have a better ontology, a broader adoption, and this is really something very important that we can try to achieve. I would add one last thing, which is, of course, there are the discussions also about the SIM model and so forth. So what I see in my experiences and what we're also looking in Interconnect is also how can we maybe extract from SIM some parts that can we use in SAREF or with SAREF, which are, of course, SIM is a very detailed data model, so we cannot think of taking everything, but just some parts for the use cases that imply and need some interoperability, high-level interoperability, then we could try to extract them in there. And what I see, and also in my little experience with some exercises that we did for a study for the European Commission a few years ago, is that being SIM in UML and such a big model, we had to translate SIM into OWL. So we did a translation, basically generated automatically some RDF OWL from the UML, but that's always it has some kind of interpretation or some. So it would be what I would also be interested to know if in SIM there is there is any plan to really make an ontology of it, but really make it. I know that UML also can be considered ontology, but knowing if there is any plan then to make SIM as an ontology also in OWL RDF, because this could be very useful if there is one unique OWL RDF of SIM or part of SIMs of SIM that can be used as reference from others, like also in our case from SAREF, in order to see if there are concepts in there that we can directly reuse instead of creating our own concepts ourselves in SAREF. And I think this concludes my what I want to say. And again, there are some backup slides, but this will be just for you as a reference. Thank you very much.
Thank you, Laura. Thank you, Laura. We need to move on, otherwise we will have no time for the discussion. Pierre Bourreau, the floor is yours. We have to get another outsider's perspective, and outsider in a good meaning.
Yeah, hello. Thanks a lot for inviting me first. So I will just start first with introducing perhaps my company, Novatec F4. So a few things. We are just a research center in France, and our expertise is on environmental transition of the building sector. So our focus is really on buildings and not really the higher scale, let's say, some neighborhoods. Sometimes we work on neighborhoods or territories, but we are really focused on buildings usually. So I'm not at all an expert on smart grids, but I can speak more on what's happening inside a building. And perhaps when we mentioned the interoperability, I think interoperability between the building and the rest of the buildings, or buildings and the smart grid, is also a topic that really interests us. So we are an RTO, doing many things, but basically working on energy consumption, life cycle analysis, circular economy, air quality. So any environmental aspect of the building, and we develop digital solutions for it. We also develop some products like solar panels installations, and we do some collaborative research and development and technology transfer. So that's it basically. I'm more the IT guy at Novatec, let's say. So I'm in charge of the development of software and digital solutions that we do. And the story I can tell you, and I think that it's the closest to what we saw today. It's about BEM server. So it's another H2020 project. Well, BEM server is the result of this H2020 project, which is called the Hit to Gap. And basically what we've done is to develop a platform and to monitor energy inside a building and to try to optimize the energy consumption inside this building. So we have a multi-layer platform, and what we are trying to do is to develop what we call now, perhaps this terminology will be familiar to some of you, but it's a kind of a building operating system. And the idea is to have this system and then to facilitate the integration of services developed by other parties. So it's kind of a middleware, so that you don't care if you develop a service, you don't need to care about where the data come from. You don't need to connect to the sensors, the actuators in your building. You just need to connect to the APIs that we are delivering, and that should ease the integration process and the deployment of a modular solution So on each building, you can deploy a different solution with different modules and so on. So, I mean, at this level, at the building level, we are already trying to solve some kind of interoperability as well through the deployment of these REST APIs. And so the service connects to the sensors transparently. And the architecture we used is quite it's quite similar to what we saw with the SGAM and the SGAM++ that you propose. So we have a field layer where you have all the sensors, actuators, the BMS, etc. And then you want to store all this information, and you want to add some information. So I think that's close to your to the information layer that is mentioned in the reference architecture that you're proposing. And we are actually also using some ontologies in there. So the current version, so it's based on IFC, which is the open standard for BIM models, or building information model. And we were also adapting the haystack referential. So I can say a few words about haystack. It's an American project actually, and the idea of this project is to be able to tag the time series that you are able to upload in your platform, so that you have information about the frequency of acquisition, about where the sensor is installed, about what the units you're measuring, this kind of information. So we tried to translate that into some more standard ontology language, RDF, OOL, and so on. And so the idea is to have metadata associated to our data points, so that we can know what we are really measuring and where in the building, and is it associated to a particular system inside my building, I don't know, the solar panel, the heat pumps, and so on. And yeah, basically that's what we are doing in there. And then we are delivering the data through REST APIs to the different services. So basically the service, when it's installed, it just has to ask the BIM server, okay, I want all the, I don't know, the temperature measurements associated to the heat pump A in the building, and you get the data this way. So yeah, you don't need to know exactly how the data are taken. One more comment perhaps on this solution, it's that it's an open source solution. So BIM server is open source. And so I take this opportunity because I saw that it was mentioned in the first presentation. And yeah, so the reason why we did that is that, yeah, I think it's a really good way to try to federate a community around a referential, which is not just an architecture in this case, but you go further because you try to open the product so that everybody can be part of the development of a product. And so the reason why we did that is not just to try to federate a community, but also because in some way the added value that you have in such an architecture is not on the data and the data you store, but it's on the services you can add and you can deliver to your end users. So really, it's the upper layer, the modules that deliver service to your end users. So at the module level, you can have your every module developer can have their own business model, and the PREM server can still be open source. So that's the philosophy behind that. Yeah, so maybe a few words to finish with that. We are now really interested as well in modules that can interoperate with the smart grid. So the next level for us would be to have modules that are able to exchange information with the grid. And I think what would be nice to do that is to have perhaps some standardized APIs that allow you to interact with the smart grid, and and it's independent of who rules the smart grid, the technology which is out of the walls of your building regarding the smart grid and so on. So I think that's what would be really interesting for us. And actually also there are some initiatives that I want to mention to you. So there is an initiative in France. It's handled by an organization called the Smart Building Alliance, and their idea, they are working on what kind of services we can deliver to a smart grid, like a smart building can deliver to a smart grid. So they are interested in that. So perhaps people at EDF or Dialog know a bit this referential, but I think it's something quite interesting to look at. And also at the European level, there is also the smart readiness indicators. And the philosophy is kind of the same. So it's like you want to certify that your building is smart enough to manage the energy it consumes or produces in a smart way. And those indicators are like how smart is my building and how easy it will be to integrate it in the future to a smart grid or to deliver energy services. And I think this is something that's quite interesting to your community, to my community, and it would be nice to cooperate around. So that's it on my side.
Thank you, Pierre. And we now need to move on to the final speaker, Massimo Bertoncini from engineering, really active in many Horizon projects as well. Massimo, the floor is yours. Try to be brief.
Yes. Could you hear me, Kalle?
Yes, we can hear you.
Hello? Yes, thank you. So my name is Massimo Bertoncini. Just very few words on myself. I'm actually working as a senior innovation manager on the digital energy within engineering informatica, which is a very large ICT company headquartered in Italy, with a very clear orientation in digitization of the energy, and very active, as you said before, in a variety of H2020 projects. I'm even, okay, thanks for the slides. I'm here just to tell you about these projects, H2020, Bid for Energy, where we are dealing with a variety of reference models and reference architecture with a view to support this perspective of cross-sectorial and energy-centric reference model architecture. We are actually in between to leverage on this effort and reconcile them with a view to create the playground towards European energy data space. If you can move towards the next slide, please. You can see here how what is about our vision. On the left of your slides, you can see a number of initiatives in between DG Connect and DG Energy. So we are actually moving in between the different legislative framework and even the measure technological frameworks. So we are actually along this and a number of other projects reconciliating efforts within Big Data Value Association, Gaia-X, IDSA, Fiverr, OpenDI in particular, while considering the EC data strategy, while as well addressing the DG Energy package, so clean energy package, and even Bridge Working Group 4 on energy digitization. I'm actually participating in this Working Group 4 in NativeNet and Nets, with a view just to deploy a reference architecture, cross-sector, based or anchored on the energy sector, and to go towards a first of this kind boosted demonstration of IDSA compliant and Gaia-X compliant architecture. So this is the the common playground. There are even common partners where I'm actually the coordinator, so TNO and even European Dynamics among the speakers for partners of this project. If we could be moving forward to the next slide, please. You can see even zooming on actually work in progress reference architecture. So if you press the button for the bullet point, please, Kalle. Okay, you could be going on. You can see how, to what extent we are actually working on leveraging and reconciliating a variety of reference models or efforts, ranging from IDSA, which as well is one of the BD for energy partner, exploits and continuing the experience of OpenDI, Fiverr, while hybridizing even with GAN models and even being compliant as much as possible to these very nice efforts deployed within Bridge on this cross-sectoral architecture. And giving you some specific information, this is a multi-layered architecture. You can see, if we could be zooming on the data management and governance layer, that we are going just to deliver an IDSA compliant, decentralized and sovereignty preserving architecture, which is able to trade off data ownership versus management from one side, while offering the opportunity to have a seamless data access brokerage. And the idea is just to deploy or to land towards an hybrid data sharing models, which is able to combine the benefits from IoT and the benefit for keeping data, not uploading data, but keeping data under the full control and ownership and sovereignty of the owner of the data itself, while considering and exploiting even the benefits from the blockchain in order to offer the necessary traceability and control. So this is in a nutshell what we are doing in this project, which is fully at the interplay between all the different initiatives, leading on initiatives on this cross-sectoral perspective. And please go on the next slide. You can see here how we are going just to take into consideration our partner IDSA defined principle for data space. They published a very nice, a very interesting paper on how to define specifically this cross-sectoral data space, and this is something that they already did in the framework of the H2020 OpenDI projects. Okay, and here you can see how this heritage or this know-how from IDSA has been incorporated in order to deploy a cross-domain reference architecture within OpenDI. What is important to add on the top of this work, which has been done by OpenDI, is that this is something which is based on some sector which are a bit more ahead with respect to the reference architecture flavor and perspective, just to explain that normally the industry and the automation, the industrial automation sector is a bit high with respect to the reference architecture and cross-sectoriality. And in that respect, OpenDI was starting from industrial automation in order to see how this flavor and this perspective could be even extended to a variety of other sectors, ranging from electricity, but even including health and even other sectors. This is even the work which has been done even by Open is involved as well. Next slide, please. Here you can see that one of the major efforts which we are going to align is just to leverage on the fiber smart grid vertical reference architecture, where engineering is one of the founding members. So all the BD for energy deployments are compliant in a native way to this multi-layer stack, which is vertical oriented just to support all the energy process, or energy business process in that respect. And my last slide, please, just to introduce even the work which we did already. Here you can see a first draft attempt on mapping the BD for energy conceptual architecture towards the already presented bridge cross-sectoral data architecture. So in red, you can see how the components from BD for energy maps very well with, for instance, with the ones incorporated and presented in the bridge work, while in yellow you can see some components which are incorporated into the BD for energy work, architectural design, while maybe they are not still there in the bridge cross-sectoral data architecture. So this is my last slide, just to conclude that we believe that just to push on this further, of moving ahead on this, I would say, cross-sectoral data architecture in a view to be able to hybridize the typical of GAM modeling, where energy stakeholders are more familiar towards this cross-sectoral, as was envisaged by European Commission this morning by Mrs. Giulia Serra, to achieve this political target, just to go towards system of system or to energy system integration. This is the right, I would say, path to achieve this strategic objectives. And from my side, I would be even happy to answer the questions raised by the audience. Thank you.
Thank you, Massimo. And we go on to final 10 minutes. We can address a few questions we have. I ask all the speakers to switch on their cameras if you can. I first addressed the question from the beginning from Willem Strabing, and his question was on the EVIX. So he wondered where was the EVIX on the reference architecture figure. I can say that the EVIX was in a way addressed from different perspectives. First, of course, the role model. So we had this role model sublayer there, but also EVIX is dealing the business requirements or business process requirements as well, message exchange requirements. So maybe not explicitly there, but of course this is something we need to keep in mind if we know about different methodologies how to map and describe the use cases. Then starting from the last questions I see here, one is Pierre to you. I don't know if you can see the question, but the question is on the PEM server. Are you converting the tax system to an ontology? Is this from Haystack ontology open source?
Yeah. Okay. So trying to answer that question. Yeah. So yeah, basically the data model we are using, as I said, it's mainly based on IFC, other more or less standards like SOSA, QDT, and Haystack. And IFC, SOSA, QDT, they all have a formal ontology format, so OL, LDF, but Haystack didn't have at the time we started the project. So we did our own conversion of the Haystack tagging model into an RDF model. So nowadays there's still an American initiative which is called the BRIC schema, which is really the evolution of Haystack into a formal ontology. So yeah, perhaps we would do it a bit differently if BRICS was on at that time, but currently that's how the data model is done.
Thank you. The other question is to Laura. When you say semantic interoperability through SAREF, does it mean that you will make any new concept used as part of SAREF extension without using other existing ontologies?
What we're doing now, so what you have to consider is SAREF is an ongoing work ontology, so it's very dynamic. It evolves with the people, with the use cases, with the adopters and so on. So definitely new concepts are and will be added in SAREF. In this moment, I can tell you that there are some concepts from Interconnect because we are 50 partners, 7 pilots. So of course, there are concepts that we don't have because we have so many use cases now, more than the ones have been originally used for SAREF. And the parts of it, for example, are concepts relative to regarding user profiles and preferences, which currently, as you've seen, is very centered on devices, but we don't have anything about that. About forecast and time series, because a lot of, well, we have to deal a lot with services with the forecasting of what energy, and not only, because there is also a lot of other forecasts that you can do. So this is one of those. Many more devices, because now there are certain devices in SAREF, but there are more and more and more devices, which are some related, of course, energy consumption and production devices, but also a lot of other sensors and actuators that we are finding and using in the pilots. And of course, there is a very important part, which is the flexibility part with also the smart grid connection. This is a huge work that needs to be done, and we will definitely reuse what's already in there, because that's one of the principles also of SAREF. So it's something will need to be added and reused. And well, we will start with something Interconnect, but it's a call for really work together in the coming time, also with other ontologies, and see how we can combine things together to strengthen each other and complement and improve each other.
Thank you, Laura. There was another question about the timeline to set up the SIM repository, which was presented by Eric. I think Eric is not here anymore, but I can tell that this is also part of the ongoing work of Bridge. So we will restart the actions this year again very soon, as well as on the reference architecture. In the beginning, there was a long question or rather comment from Chavdar Ivanov. I don't know, Chavdar, if you are still here, you can unmute yourself and make your point. Maybe not, or it takes time, but more or less what he writes is that clearly define use cases and business requirements, define data structures and architecture, test the feasibility of it, standardize, etc., etc. So I very much agree, and I hope this is exactly what we're doing inside the Bridge, but also in the frame of the data interoperability implementing acts as presented by Georg. And I think it's probably also clearly the focus of SAREF, for example, so there's no doubt in that. So maybe just the kind of concluding question to all, that, and Laura kind of started it, that how we actually can integrate SAREF and SIM, SAREF being ontology, SIM being canonical data model, and even beyond. I mean, there are other initiatives, other reference architectures, other reference models. So how can we really actually integrate them? And are there some kind of major differences for which we actually cannot integrate them? Who would like to take the floor first?
Kalle, this is Massimo. Could you hear me?
Yeah, please.
Yeah. Yes, my quick comments on this is that just to make you aware that this is one, as was in my slides, one of the actual ongoing objectives in the BD for energy and even other projects. The main reason why is that, for instance, CIM, it is even mostly, you know, dedicated or was originally born just to support some of the business process of the electricity operators, so even to substation. So it is something which is mostly was mostly initially related just to the field operation to support, you know, operation if not markets. In the project, in this project, what we are actually doing with specialized partners, it is just to try to hybridize, just to take the benefits of the two different approach and to try to hybridize CIM, automation-oriented or market-oriented protocols with SAREF for energy or even SAREF for building. Let me remind even another peer projects which we are coordinating, H2020 Matrix, which is mostly working on the hybridization integration of mostly building data with energy data, and so even to move further ahead, even this this integration between CIM with having a more smart energy grid perspective, and even jargon from SAREF, in particular SAREF for energy and even SAREF for building. So this is an ongoing attempt. So my comment is that it is something which we can work. I cannot see any, from my perspective, from even the experiences which we are doing, any blocking, I would say, issues which may prevent this to move ahead in that direction. Thank you.
Okay, thank you, Massimo. And anyone else, final chance to intervene? Laura, please.
Yeah, I agree. I don't see any obstacles in the sense of it's something that needs to be done and started. I think it could be a big work, but nothing prevents us from, of course, starting. And the two models, of course, as has been already highlighted, they have different purposes. So we also need to see which parts we want to, it's good to combine them together somehow, but then to provide some type of pointers of one to each other. So for the details, we will use the same. For the interoperability of certain parts that we need to communicate to others, then we will use SAREF. And then how to make these two things together. To me, a first step is, of course, these are two data models made on different, so we do have a UML data model mainly and an ontology formalized in RDF OWL. So the first step, well, at least for what we would need from the service perspective, is to understand, to translate same concepts into RDF OWL in a unique way, standardized way that people can use. Then the question is, what should be these concepts? Where do we start? From which subset of concepts for what? And then start building up on that. Because I don't know if it's needed to translate the entire SIM model into RDF OWL or not. So these are the first thoughts I have and the first places where we could start looking at, in my opinion.
Thank you very much. Thank you. So to sum up, we as Bridge Initiative, we plan to work further on the topic this year as well. And this is what I see has been asked by one person. And the last question I see now, does this group plan some partner matching or pitching sessions for the upcoming Horizon Europe and Digital Europe calls? I can only say that this work is already going on. People are talking to each other. So just feel free to contact any of the person here. I think most of us are and will participate in Horizon projects. Thank you very much. Thank you, all the speakers. Thanks to audience. You have been patient, at least most of you. And final thanks to our backstage support, Eileen Caroni from Bridge Secretariat, representing Zabala. Thank you. Talk to you soon. I'm pretty sure we need some follow-up activities here. Goodbye.
Goodbye, everybody.
Bye-bye.
Bye.
Bye, everybody.
Thank you very much. Goodbye.
Thank you. Bye-bye.
Bye-bye. Thank you.